Next up, we have Rajul Jha, who will be giving a talk on automating license and copyright scanning in CI pipelines with FOSSology. Over to you, Rahul. Rajul. My bad.
Not the first time. Uh, Hi everyone, and welcome to the talk. And I hope you guys had tea. And I see a few sleepy faces in the crowd. And there's a good news for you because I'm going to be telling a story which would essentially put you to sleep. So yeah, that's a great thing for us. so today's topic is automating license and copyright scanning in CI, which is continuous integration with Fossology. So before we talk about anything else, let's just talk about me. Myself, Rajul Jha. I worked in Fossology during Google Summer of Code for the past 2 years, and I'm a full-time computer engineering student, final year student at Aligarh Muslim University, and I like to code and I like Python. But this brings us to the story. Enough about me. Now let's talk about Bob. Who is Bob? Bob is our friendly neighborhood developer. Just like all of us, Bob has faced a problem. And what do we do when we have a problem? Just like us, he went online and looked at some open source code that solves that problem, right? And Bob decided to use the code. He committed the code. He raised a PR. The PR got merged. Everything right, right? Is there scope for improvement? What has Bob missed that has made his life miserable, and that might lead to a future problems for Bob? We all have been Bob at some point in our life, and what Bob has missed, essentially, it is a very easy thing to miss, and it is really forgettable thing, which is license compliance. Things we are going to cover in this talk are what, why, and how of license compliance, how we can automate all this stuff using Fossology and FOSSOps, which is a GitHub action, by the way, and implementation and configuration options, some other features and use cases. So, starting with what is license compliance? So license compliance is it just basically refers to an agreement on how and what parts of my code you can use. So there's a very famous license called the GNU General Public License or GPL license. So it has a very strong copy left requirement, which essentially means is if you use a code that is licensed under the GPL license, then you also have to license your code under the GPL license itself. And on the other hand, the MIT license, it is a more permissive license, and it allows you to use the code in whichever manner you want, with just the requirement that you have to uh, give credit to the original author of the code. So this is all about license compliance, and the method through which we assure that the people stick to these requirements that are defined in these licenses. It's generally known as the license compliance. So you might think, why license compliance? Like, why is there a need for such a thing? What is the impact of it? Just to put things into perspectives, here are some numbers for you. So the Open Source Security and Risk Analysis report, OSSRA, which is published by Black Duck, it's a very famous report on the security and risk analysis. It has shown that over half, that is 53% of the code bases in 2023 that were audited, the open source code bases, they had licenses with conflicts. It's such a huge number. It's more than half. And if you think about the repercussions, these are massive. These are skyrocketing. For instance, I remember there was a legal battle between Apple and Samsung, which led to a $1 billion plus lawsuit, which was settled a few years back. And like these are just the repercussions that we are talking about. So you might think, like, why is there such a big number of license conflicts? You might think, why is that? The reason is simple. Every major project has thousands of files, right? Thousands of files with hundreds of lines of code, and in case of some Linux components, these can even range to lakhs of files or lakhs of lines of code. So it's a really tedious task to check each and every file manually. So this is the exact problem that Fossology solves for you. So FOSSology is an open source license compliance software, which essentially has a web interface. We have a whole complex ecosystem which allows you to upload the files, upload zip files, upload source code, etc. And it scans for license vulnerabilities, copyrights, keywords, and all of these things inside of your code. And before talking about FOSSology a lot, I would like to show you how a particular piece of code can be attributed to a particular license. For example, in line number 5, you can see there's a special statement called the SPDX license identifier. So it is a special keyword which is a standard enforced by SPDX, which is Software Package Data Exchange. So this means that this piece of code has been attributed to the GPL 2.0 only license. One another way in which we can attribute some code to some piece of text to a particular license is using copying a small snippet of the license itself and pasting it inside of the code in the form of comments. So this is another way in which we can attribute a particular piece of code to a license. So how FOSSology detects licenses, it uses all of these identifiers, these regular expression patterns, certain set of keywords. For example, you can see redistribute, published, distributed. All of these are keywords that are researched by our contributors. They have been contributed to FOSSology, and these keywords have been known to attribute to a particular set of license. So in FOSSology, we have a concept of agents. Uh, we have a concept of agents for a few years even before it was a cool thing, and agents have nothing to do with AI. So sorry about that, but these agents have the responsibility of scanning for particular piece of text inside of the code. Like for example, there is an agent called the Ojo agent inside of FOSSology, which is responsible for finding out these SPDX license identifier keywords as seen on line number 7. And whichever license is present after that statement, it attributes that file to that particular piece of license. On the other hand, Nomos is another famous agent which also works on the rule-based approach. It searches for these particular set of keywords like redistribute, publish, and all that, and it classifies the file as to a particular license using that format. So this is a FOSSology's web interface. You can see like the file that I have uploaded. It has highlighted the information which attributes, which indicates the presence of a particular license. I can zoom in if you want. It has highlighted all the information which might lead to the indication of a license in the text. And here it shows which license has been identified in the file, which is a GPL 2.0 only license. So that's all is good. Like we can upload all these files and all that. But you might think like it's such a tedious task for me to set up. I have to upload all these files, right? So this brings us to a question: what if? What if we could automate this? In order to do that, we have FOSSOps. FOSSOps or FOSSology's GitHub action. It is a simple GitHub action that allows you to introduce license compliance inside of your CI pipeline itself. It's a simple 6 to 7 lines of YAML configuration, which would have saved endless sleepless nights for Uncle Bob. And we all have been Bob at a certain point in life, right? We all have taken code that solves our problem from open source repositories and have added it to our code base. So we all should have taken care of all these things. Like since Uncle Bob has taken all of this code, and he might have faced problems later on in his life. So in order to avoid all these problems, if we would have added this simple check, which is our 6 to 7 lines of YAML, then we would have been saved from all that. So this is the this is the interface that we see after the GitHub action has run successfully, and the job has run, and we publish the report results in the form of an artifact which can be downloaded later on. And these are all the just the things. And yeah, this is how the GitHub action will show the results. It will pinpoint the exact location of the potential license violation that has been found. For example, like in this, it has found at nomos test file /al license derived from keyword has been found at line number 26. One thing that I would like to make clear here is FOSSology does not tell you whether your license is compliant with whether two licenses are compliant with each other or not. It is just a simple tool for finding out exactly where a potential license, keyword, or copyright statement might have sneaked into your code. And it essentially allows you to pinpoint the exact location, and then you can take care of that later on. You can contact the compliance officer or whatever that is responsible for this inside of the organization. Yeah, so coming back to FOSSOps or FOSSology action, we have a bunch of configurations. So each project has a different set of needs, and in order to fulfill all those needs, we can run the GitHub action in different configuration modes. Like these are the different scanning modes that we can run the action in. First one is the diff scan. It essentially scans for the like the diff of the code. As we can see, only the diff of a particular commit or a PR that we have raised in the PR. And another mode is repo scan mode. So like it's a good use case to run this diff scan mode on every PR or every push to a particular branch or whatever. And in the repo scan mode, one interesting use case is, let's say for example you are adding a whole new repository, a whole new folder, or whole new repository to your organization, and you want to make it and you want to check whether the code is compliant or not. Then you can run the GitHub action in the repo mode, and whole of the repository would be scanned, and all of the files would be scanned for violations and whatnot. Another mode is differential mode. So it essentially allows you to scan two different versions of your repository. By version, what I mean by versions is, let's say you have a previous release for a repository, and you're making a new release, and you want to compare the current version, the current release that you have, with the previous releases that you had. So if you want to configure that in the from tag and to tag section, you can essentially write down whatever version from you want to compare and whatever version to you want to compare. And here even you can, if you want to compare two commit shas, then that's also possible. You can compare two commit shas. You just have to write from tag and to tag pointing to those commit shas. And one interesting use case for this is running this scan on any new release for the repository. Yeah. The next scanning mode is a dependency scanning. So as we all know, like in a mature project, the project code base is not enough for scanning. We also have to scan the whole of the dependencies of the project that the project has. So in this regard, what FOSSology needs as an input is an SBOM file. So SBOM is software bill of materials, and it essentially has whole information about the project, the version, the spec. We currently support the Cyclone DX format. So Cyclone DX format, and it has components, and components essentially mean all of the dependencies of your project. Everything about the dependencies of a project is listed in the components fields. And what essentially FOSSology or GitHub Action does is, it goes into the SBOM. It looks at all of these components, as you can see, and it looks at the package URLs, which is Perl, and it goes to the registry, which is in which the package is registered. It downloads the whole package locally into the GitHub's runners environment. Then it runs the FOSSology's actions binaries on top of the downloaded code, and it returns all of the results from this scanning. One potential drawback of this dependency scanning is it does not support transitive dependencies yet, because we work with the SBOM files, and SBOM files have only a single layer of dependencies, at least in the Cyclone DX format. So transitive dependencies are not yet supported. So which means is it will only scan the immediate dependencies of a project, not the dependencies of the dependencies, and so on. So that is one potential drawback. And yeah, so next feature is allow listing. So what do you mean by allow listing? Like for example, let's say we have come to PyCon, and we all have these ID cards, and we have scanned the tickets. So essentially, these tickets have allowed us entry into the PyCon conference. So that is essentially what allow listing is. Allow listing allows you to at start, Fossology does not know which license is okay for you and which license is not. So you can tell Fossology कि this license is okay for me by adding it to a special file called the allowlist.json file. And in the licenses key, you can add any license that is okay for you. For example, like if you're building a project that is licensed under the GPL license, then you can add the GPL 2.0, GPL, or whichever. If the sister licenses of GPL like GPL, LGPL are also okay for you, then you can add those licenses in the licenses key field. And then Fossology would not detect these licenses as the potential vulnerabilities. Any licenses apart from this, they would be termed as potential vulnerabilities. And you can even exclude particular directories or particular files from being scanned by giving the blob format from them. For example, in this case, whole of the .github folder, it would be excluded from being scanned by Fossology. And anything which has agent tests in its path, it would also be removed from scanning from Fossology. Uh, Next, or another interesting feature is keywords. So it Fossology already has a keyword agent that scans for a particular set of keywords that have been researched by our contributors. But apart from that, you can scan your keywords as well, whichever might be a problem for you. You can scan them also. So you have to give the regex pattern of whichever keyword that you want to scan in this keyword.conf file, and you can specify it inside the GitHub action as well. And it essentially would allow you to scan for particular set of keywords inside of your diff or repository or differential in whichever mode you want to scan. For example, like in this case, it would scan stolen space all from. So it would scan everything that has something like stolen from, stolen and taken from, and everything like that. One interesting use case for this is, for example, say you have added a new repository, and you got to know from somewhere that okay, passwords might have creeped in into the repository, they might have been committed directly. So you want to scan for the keyword password inside of your whole repository and see, like, by mistake, if no passwords have been committed. So you can add password as a keyword into this keywords list, and then Fossology would identify each and every place where password is. And another interesting use case is, for example, if you have taken the code from a third party, you can enforce your developers to code that this code has been taken from this third party. For example, like if I have taken some piece of code from Stack Overflow, I can enforce my developers to write in comments, to comment like taken from Stack Overflow, and then I can add taken from Stack Overflow as a keyword inside of my CI check. So essentially, what I'm doing is I'm allowing my developers and I'm allowing myself to take care of all the stuff that potential non-compliance that might have crept into my repository. I can take care of all these things in an automated manner. Like, I don't need to drag and drop and upload this file and whatnot. I don't need to maintain a database and all that. I don't need a Fossology instance running. It essentially is just simple YAML configuration. Uh, Also, if you want to share the reports that is generated by Fossology, you can do so in particular formats, like the SPDX, JSON, YAML, RDF, tag value. All these are just formats in which you can generate reports. So by default, Fossology generates the report in text format, as I showed you earlier. This is the format, like it would show the output in the GitHub runners output logs, but you can also generate it in the form of a report in these whichever formats. And you can essentially pass these reports to inside your organization or on your communication forums to keep everyone on the same page. uh, we have talked a lot about Fossology and all the configuration options, the different use cases, but let's now talk about how it works. So inside of Fossology, we have a concept of agents, as I told you earlier. So these agents, they are built independently from each other. So for example, if I zoom in, uh, I have listed down 4 agents, which are Nomos, Ojo, Copyright, and Keyword. All these have pre-compiled binaries, which can be used as a toolkit these have a binary that can be run from the CLI as well. So what we essentially do is we have an automation module, which I worked on, by the way. So this was automation module. It essentially lives inside a Docker environment, and we copy the binaries of these pre-built agents inside of the Docker environment, and allow the automation module to run these binaries on whatever code that we take from CI providers. So currently we support GitHub Actions, GitLab CI, and Travis CI, and these communicate with our module using REST API calls. And essentially, depending on the mode that we have specified, whether it is diff or differential or repo, it downloads the code inside of the GitHub Action runner, or inside of the Docker environment, sorry. And essentially, the agent binaries are run on top of the extracted code from these CI environments. And then the results are, and then the reports are made using the SPDX format, and then the reports are sent back to the user. And what FOSSOps does is it essentially uses this Docker image that is published to the Docker Hub registry. It just pulls in this image and does all of this stuff that I mentioned inside of a GitHub runner CLI, a GitHub runner environment, and then publishes the report as an artifact in the CI pipeline. So this was all about the configuration options, right? So one thing that I wanted to talk about, or wanted to encourage others or other developers to take on is, it's one thing to write code. Like we all write code, and we all want to write good code, but it is also important. It is also important that we write code responsibly, and we take care of these things that might lead to uh, future problems. So we have all been Bobs at all time. Like everyone has taken code from open source, right? And but the thing that we need to care about is, we if we do it, we should do it carefully. I am just not telling you all this. These are the companies and organizations that are using FOSSology currently, and for FOSSology has been around for a long time now. I think it was started in 2013, so there have been 12 years since it has been around. And if you have any questions, you can join the community. You can ask questions on Slack. We are fairly active on Slack. You can scan this QR code to join the Slack channel. We have a GitHub. Don't worry, the link to these slides is available in the last slide, so you can download and scan it later. And these are just the references for the talk. And thank you so much. And you can scan this QR code to download the slides. And if you have any questions, then I'll be more than happy to answer. Thank you. Yeah. 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 Mm-hmm. Yeah. 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 So yeah, in that case, like if you're using Apache license for a repository, then you can add it in the allow listed license. So it would not detect the presence of Apache license, but any license apart from Apache, if it is present there, then it would detect it as a potential vulnerability. It would not modify the repository in any sense. It would just point out, okay, hey, this license is present at in this file at this location. So you can go and check it out whether it is compliant with your license or not. Yeah. 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 Yeah, as of now, there is no direct way to check all the transitive dependencies. One thing that we can, like one workaround for this is, like if you have some way of generating the SBOMs for each of the transitive dependency, then you can add that SBOM into FOSSology action, and it would scan each SBOM and and it will scan the dependencies of each of the like it would scan the dependencies of each of the dependencies depending on the SBOMs of each dependency. So that is the only workaround that is currently available. But like we are working on providing that feature, uh, but that's a long way to go right now. Yeah, that is actually that is actually, but FOSSology, it has a bunch of tools that are built around Cyclone DX format. So that is one potential thing. Yeah. Yeah, we can build the SBOM as a CI step itself using Cyclone DX itself. Like we have to build it externally, but we can feed it inside the CI pipeline as a separate step just before running FOSSology. Yeah. Yeah. Yeah, sure. FOSSology, like it has a whole ecosystem, and you can go to github.com/fossology/fossology, and the whole repository is available. And there are a bunch of dependencies, like and the setup steps are also clean. And you can also use Docker to like you can run using Docker as well, or you can compile it from source as well. All of the things are available. Yeah. Thank you so much. Yeah. 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 Yeah, no, that is not currently supported. It expects an SBOM file only. Thank you so much.